All right, well, here we go. Let's just jump right ahead onto how to add when we don't have like terms. All right, so let's maybe look at a quick example. Let's say we have 2 over 3 plus 5 over 4. Okay, well, if we want to combine this, right? Well, are the denominators like terms? Well, no, it's not. It's 3 and 4. So in order to get like terms, well, we need to multiply essentially the opposite. 3 over here, and we need to multiply 4 over here, right, to both sides. Therefore, 4 times 2 is going to give me 8 divided by 12 plus 15 divided by 12. Okay, now we can add it across. 15, 16, 17, 18, 19, 20, 21, 22, 23 divided by 12. So here's an example problem where we have to have like terms in order for us to continue and actually add the numerator expression. Here we don't have like terms, so we had to multiply the opposites, right? So now let's go on an example, even maybe an example that I could say is maybe less challenging than even maybe the one up above, right? So let's say we have 4 divided by x plus 7. Well, we're going to need to write this as 7 over 1. Okay? That way we could see, well, what are we missing in order to have like terms on the bottom? Well, we can multiply this side by x, multiplying x on top or bottom. Okay, and therefore we're going to obtain, well, we're going to have 4 over x plus 7x divided by x. Now that we have the same like denominators, again, when we're adding, the denominator stays the same, and we're just going to get 4 plus 7x. And this is my final expression, right? 4 plus 7x divided by x. We're done. There's nothing much that we can do at this point. You should feel pretty confident that this is your final answer, because the 4 does not have an x. We can't combine like terms, right? So we're done there. So now maybe let's look at another example that might require us to combine like terms. Okay, so let's say we have something like 3 over x plus 4 divided by y. Well, we need to have like terms, so we're going to have to multiply both sides. Okay? This side I'm going to have to multiply y to both sides, and over here I'll have to multiply x to both sides. So we're going to get 3y, I'm just rearranging it, divided by x times y. Or if you want to, we could just write it as y times x, it's up to you. Okay, plus 4x divided by y times x. Okay, last but not least, this is going to be 3y plus 4x, all divided by yx. Again, the denominator stays the same. Okay, so you can see that all we're doing is just trying to get like terms on the bottom. Now, let's go ahead and look at maybe something that's going to require us to have like terms right on the bottom. Let's look at maybe something like, let's say x divided by x plus 5. Okay, plus 3 divided by x plus 3. Okay, well, this is going to be a little more challenging because we need to get like terms on the bottom, and it's essentially the same principle that we've kind of had over here, right? We just multiplied the opposite, or up here, right here, you know, this was a 3, so we multiplied 3 top or bottom. This was a 4, so we multiplied over there 4 top or bottom. So now that we have this here, well, I'm going to, you know, maybe I'll put some parentheses around here just so that, you know, doesn't confuse us a bit. Let's just put some there. Okay, well, I'm going to get, over here, I'm going to have to multiply x plus 5 to both sides. And over here, I'm going to have to multiply x plus 5 to both sides. And over here, I'll have to multiply x plus 3 and x plus 3. Okay. Therefore, I'm going to get, we're going to have x times x plus 3 all divided by x times 3, x plus 5, plus 3 x plus 5 all divided by x plus 3, x plus 5. Okay, now I'm going to turn this into a single fraction, x plus 3, x plus 5. Again, the denominator stays the same. Okay, and now I'll go ahead and simplify the top, right? Well, x times x is x squared, x times 3 is going to give me plus 3x. Over here I'm going to get plus, so plus 3 times x is 3x, and 3 times 5 is 15. Therefore, my equation is going to be x squared plus 6x plus 15, all divided by x plus 3, x plus 5. Okay? Well, the question is, can I find, let's write all the factors of 15 in this corner, right? 1, 15, and 3 and 5. Well, can I add or subtract any of these to get 6 here? Well, unfortunately, I can't, right? So there's nothing I can do to turn that into factored form. I'm pretty much done. There's nothing left for me to do. And so therefore, my final expression is going to literally just going to be the top part, x squared plus 6x plus 15, all divided by, well, x times x is x squared. And then I'll do this in my head, right? 5 plus 5 is going to give me 10x. And 5 times 5 is going to give me 25. And this is going to become my final answer, right? I couldn't cancel anything out to try to put it into factor form. So if I couldn't, I just go ahead and multiply across. All right, so hopefully this helps you to understand how to combine like terms with these essential problems here. Thank you very much.